Good morning, students. Today I will teach you second qualitative properties, which are elevation, elevation, elevation in boiling point, elevation in boiling point. So, if we will explain about it, then when non-volatile solute are added to volatile solvent, then vapor pressure R decreases and boiling point R increases, and this phenomena known as elevation in boiling point. Now, try to understand it through figure. Consider we had two containers, in which firstly having solid particle which are non-volatile, and second container having solvent particles which are volatile. Now think about it. If this non-volatile solute be added to, we can say that on adding this non-volatile solute to volatile solvent, then definitely vapor pressure will decrease. I mean that on addition of non-volatile solute to volatile solvent, vapor pressure will get decreases. And again, to vaporize it, we need some temperature. Or some heat. So this phenomena is known as elevation in boiling point. Again, I am trying to explain it. Please listen properly. According to me, where non-volatile solute are added to volatile solvent, in that case, definitely vapor pressure will decrease, and to vaporize it again, we need some more temperature, and that's one is considered as elevation in boiling point. And also we can say that phenomena is known as elevation in boiling point, which are already mentioned on the board. Now I am coming to understand it through the graph. We have two coordinates y and x. On this axis, consider vapor pressure R increases, and on this axis consider temperature R increases. And again, plotting two curve. First one for volatile solvent, means for pure solvent. Now to boil it, consider here something we need temperature, and we can say that these one are T naught B means boiling point of pure T naught A is pure solvent, because every books are mentioned for solvent is considered, sorry, solvent is considered as A and solute is considered as B. So these one are boiling point of pure solvent. Pure solvent. And if we will add non-volatile solute, then that time vapor pressure will decrease and temperature will increase. So after adding, we need some more temperature, and here we assume T. TB. TB means on this point vapor pressure are equal, and TB is TB is boiling point of solution. Listen properly here. Are some difference in temperature. There are some difference in temperature, and thus that difference of temperature is known as elevation in boiling point. That difference in temperature are also known as boiling point. Elevation in boiling point. So see here, I mean that del TB is elevation in boiling point. Elevation in boiling point is equal to final temperature means TB minus initial temperature means T naught A. Got it? This one are elevation in boiling point, and experimentally we got that del TB means elevation in boiling point is directly proportional to molality. And again we know that if we will remove this proportionality, then definitely will come there some constant. So del TB is equal to KB, means these one are constant instead of proportionality sign, and N means molality. And this one are also equal to elevation in boiling point. Now if we coming regarding unit of KB, then we get unit of KB equal to del TB upon M is molality. We know that unit of temperature are generally considered as Kelvin upon molality is mole upon solvent in kg. Mole upon solvent in kg. So this kg will go upward, means as in numerator, and finally we will get units are Kelvin per mole kg of Kelvin. This one are second property of solution, second qualitative property of solution. Now I am going to discuss third property, which are depression in freezing point. Depression in freezing point. Depression in freezing point. Just wait 1 minute. These properties are also similar to elevation in boiling point. So listen here properly and try to understand it. Here non-volatile solute are added to volatile solvent, then vapor pressure are decreases. These one are already you know. And then freezing point are decreases. Then freezing point are decreases. Got it? Then you will add something non-volatile solute to volatile solvent, then definitely vapor pressure will decrease, and that can easily will get freeze, means freezing point will decrease, and this phenomena is known as depression in freezing point. Listen it properly again. Where non-volatile solute are added to volatile solvent, then vapor pressure are decreases. This one already you know. And freezing point are decreases, of course, because solute are non-volatile. So freezing point will decrease, and this phenomena is known as depression in freezing point. Now again, I am trying to understand through two container. We have two container in which in first container there are non-volatile solute, and in second container there are volatile solvent. And this one when added to means non-volatile solute are added to volatile solvent, then definitely vapor pressure will decrease and freezing point will decrease. And this phenomenon is known as depression in freezing point. Again, I am coming and try to understand through graph it again. We have two things. Firstly, we have pure solvent, which are volatile. So to freeze or to turn freezing pure volatile solvent, there need some extra temperature, some less temperature. So this one are T naught F for pure solvent, and on adding volatile non-volatile solute, temperature will decrease, means this one are TF and this one are freezing point of solution, just like elevation in boiling point, and this one are freezing point of pure solvent, just like elevation in boiling point. Not means pure and simple means TF is are not pure means this one are freezing point of solution and T naught F are freezing point of solvent. Again, listen here. There are some difference in temperature. And that difference are known as depression in freezing point. Got it? Again, listen here. There are some difference in temperature, and that temperature is known as depression in freezing point. Means del Tf. This depression in freezing point is represented as del Tf. So here you can also note it. Del Tf. And del Tf again equal to final minus initial, means final temperature are here T naught F minus initial temperature are Tf. Got it? And again, similar to elevation in boiling point, this del Tf is directly proportional to molality. And again, if we remove this proportionality sign, then definitely there come some constant, and their constant are Kf. Means this one are molar depression constant. Molar depression constant. Now, if we need unit of K, then definitely we will get same thing. So this one are about depression in freezing point. Thank you. All the best. Give your best. It is enough for today.